So we're going to do some more polynomial theorems today, and we'll start with a bit of a review. So recall that the word roots, the roots of a polynomial p of x, are the solutions to the equation where that polynomial p of x is equal to 0. So it's an equation. Each real root is an x-intercept of the graph. So if we find a solution to the equation where it's equal to 0, then we also have found an x-intercept of the graph. If R1 is a root of p of x, so it's one of our solutions, then x minus R1 is a factor of p of x. If a polynomial doesn't have any real roots, then its roots are imaginary. And there are no x-intercepts. All right, so what I want you to do is try this first one, kind of get back in the groove, solve it by using the quadratic formula. So notice that the graph, and once you do it, you get your solution, which will be imaginary. Notice that the graph doesn't have any x-intercepts right there. Okay, now we're ready for example 1. We're going to use this graph of this polynomial, which we got graphed right here, to answer the following questions. We're going to solve this problem where it's set equal to 0. So we're going to find its solutions. So we're going to look here and look to see where the x-intercepts are. We have an x-intercept at -2 and at +2. So x-intercepts are -2 and +2. Well, we know from what we talked about earlier that the solutions then are also going to be -2 and +2. And the factors then are going to be x minus a -2, which gives me x plus 2, and x minus 2. So those are two of our factors. We know it's not all of them, because if we were to multiply this out by FOILing it, we know we'd come up with at the biggest x squared. So we know we're missing a factor or two. All right, so the question is, what is the other factor? So first, we're going to just divide by x plus 2 using synthetic division. So we'll have -2, and we're going to put in the coefficients up here, 1, -6, 6, 24, and -40. And then do our division. So drop our 1 down, that gives me -2, that's a -8, 16, that adds to 22, it's -44, that's -20, +40, and I get what I expected right there, a 0, because it was a factor. So if it's a factor, it should have a remainder of 0. All right, so this is what we have left over. So when we divide it, we have what? X to the third minus 8x squared plus 22x minus 20. So our other factor now is going to go into this. So I'm going to next take and divide what was left over here. This, I'm going to take this, and I'm going to divide it by x minus 2. So here we're going to have a +2. I'm going to put my 1, -8, 22, and -20 right there, and divide. So I get 1, 2, -6, -12, 10, 20, and there's my 0 again, because this I knew was a factor and should have a remainder of 0. If I didn't get a 0, then I made a mistake. All right, so then my new factor then, I'm going to write this down, is going to be, if this started with x to the 4th, this dropped to x to the 3rd, this is now x to the 2nd. So I have x to the 2nd minus 6x plus 10 for my third factor. All right, well, we know that we can find solutions to this by either factoring, well, it doesn't factor, two numbers to multiply by 10 and add to be -6. But then if we can't do that, then we can do the quadratic formula or completing the square. So I'm going to finally solve this by factoring, completing the square, or using the quadratic formula. And I'm going to do the quadratic formula. So I'm going to have x is equal to 6 plus or minus the square root of b squared. So 36 minus 4ac, so minus 40 all over 2. So that's going to be 6 plus or minus the square root of negative 4 over 2. So that's going to be 6 plus or minus 2i over 2. And that's going to reduce because you see these are all even right here. So this is going to divide everything by 2, and I'm going to get 3 plus or minus I. So my final answer, all of the solutions, I'm going to list them all. They're going to be 2, negative 2, 3 plus I, and 3 minus I.